we've talked about what it means to be a midpoint, that the midpoint's right in the center of a line segment and it breaks it in half, the two equal parts. Well, we can find the midpoint if we know the coordinates, excuse me, the coordinates of the two ends. And the midpoint is the halfway point. And so what you do is, if you have, so you have your two ends of your segment. And this end would be x1, y1. And this end would be x2, y2. So you add the two x's together, divide by 2. Add the two y's together and divide by 2. And that's when you get your midpoint, which is right here. Dividing by 2 because it's halfway between the x's. I'm going to go ahead and do an example, actually, of one of these. So let's say I have this line segment, and this point is at 2, -5. And this point is at 6, 3. Okay. I can find the midpoint using this formula. So I'm going to pick a different color here. So I'll call this x1, and this one's y1. This is x2 and y2. So then I plug that into this formula. So I have 2 plus 6 divided by 2 and -5 plus 3 divided by 2, which gives me 8 over 2 and -2 over 2, which gives me 4, -1. That would be the coordinate of this midpoint. So then we can have the endpoints and find the midpoint again, just like we're going to do really, it's all animated, it's pretty. So we take our midpoint formula, we plug in our x's, 2 and 4, and we plug in our y's, 6 and 14. 2 plus 4 is 6, we divide that by 2. 6 plus 14 is 20, we divide that by 2, and we get 310. Or we can go backwards. We have an end point. Here's one end, and here's the middle, and we need to find the other end. So what we've been given is, say this is -4, 8, and this is 6, oops, that's not. This is 6, -12. So we have one end in the middle, and we need to find the other end. So now what we're going to do is we're going to take our midpoint formula. All right, so this is option 1. And option 1 is by using algebra. And so we take our midpoint formula. Our midpoint is going to equal x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay. This is x1, y1, and this is midpoint. So what I have is 6, -12 is equal to -4 plus x2 and 8 plus y2. What'll happen is this value here gave us 6. And this value here gives us -12. So we say -4 plus x2 divided by 2 is equal to 6. And we say 8 plus y2 divided by 2 is equal to -12. And then we have to solve each of those separately. So I'm going to multiply both sides by 2, and I get -4 plus x squared, x2 is equal to 12. And then you add 4 to both sides, and you get that x2 is equal to 16. Does that make sense? Why I multiply by 2 is to cancel this. And then you do the same thing over here, multiply by 2, and I get 8 plus y2 is equal to negative 24, and I subtract 8, and I get y2 is equal to negative 32. So my other end is 16, negative 32. Okay, there's another way to do it. Using arithmetic. So no algebra, no x's and y's in there, okay? For this method, you take 2 times the midpoint minus the given endpoint, and that equals the other endpoint. Okay, it's actually the same process. As you can see here, I'm multiplying 2 times the midpoint, and then I'm subtracting. Minus negative 4 is actually plus 4, so I'm subtracting the endpoint. I'm doing the same process, just without the algebra. What that would look like is I have the midpoint is 6, negative 12, and I want to subtract from that negative 4, 8. Okay, when I multiply this by 2, I get 12, negative 24. Same numbers, see, 12 and negative 24. Minus negative 4, 8. Minus negative becomes a positive, so that's 12 plus 4. And then negative 24 minus 8 gives me negative 32. So you can use the formula, plug in what you have, and solve for what's missing. Or you can use this sort of shortcut thing without the algebra. Use the one that makes the most sense to you, because for some people this makes more sense, and for other people this makes more sense. If you have the two ends, you have to use the formula to find the midpoint. That's just the only way to do it. But if you have one end and the midpoint, you can use this other thing over here. We've got a triangle, and the vertices are L, M, and N, and we're given their coordinates, and we want to find the midpoints of each side. And right now we're not going to be doing anything with that, just finding the midpoints, but later when we get to some triangle theorems that involve the midpoints of the side of the triangle, we'll need to be able to locate them. So this is just to start us to get there later. So first thing we do is we're going to draw the triangle. So you put it on graph paper and you plot the points. Now I do have a bunch of graph paper over on the shelves and on this cart if you need graph paper. So once you've plotted the points, you draw the segments, and that's our triangle. Okay, so this is the point 1, 3, then I have the point negative 1, 6, and then the point negative 3, 2. Okay, now we're going to look for the midpoints, which are going to be, somewhere roughly in these kind of areas. We're going to find the midpoints. That's the whole point of this. Okay, so any questions on what to do to begin? The reason I recommend drawing the triangle is so that you know which 2 points to use together every time. And that way you don't miss anything. Because you have to find the point between these two, the point between those two, and the point between these two. After we've drawn the triangle, we have to use the midpoint formula 3 times, one for each side. Okay, so remember this was 1, 3. This point is negative 1, 6, and this point was negative 3, 2. So the midpoint formula, again, we add the x's, divide by 2, add the y's, divide by 2. So the midpoint of LM, I need to use L and M, so I'm going to have negative 3 plus negative 1 divided by 2, and 2 plus 6. Oops. I don't want parentheses there. Okay, divided by 2. Negative 3 plus negative 1 is negative 4. So I have negative 4 over 2 and 8 over 2, which gives me negative 2, 4. So negative 2, 4 is this midpoint right here. Then I'm going to find the midpoint of MN, so I'm using these 2 points. So I'll have negative 1 plus 1 divided by 2 and 6 plus 3 divided by 2. That gives me 0 divided by 2 and 9 divided by 2. 0 divided by 2 is 0. 0 is allowed to be on top. 0 is just not allowed to be in the bottom. Because everything, 0 divides by everything. 0 divided by 5 billion is still just 0. But nothing divides by 0. Do you guys understand why that works? Okay. If I have 0 divided by 2 equals something, okay, I'm looking for this times that to equal this. So that can be 0. 2 times 0 is 0. That's okay, right? So it equals 0. But if I have 2 over 0 equals to what? I'm saying what times 0 equals 2? 0 times nothing. There's nothing out there, so that's why you can't divide by 0. So this one is it doesn't exist. So in case you ever wondered why can't I divide by 0, this is why right there. Because nothing times 0 can give me a 2. There's nothing out there. It doesn't exist. So this is 0, and this is 4.5, or you can just leave it 9 halves. Either is fine. So I have 0, and I have 4 and a half, which is that midpoint right there. And then I have 1. Okay, so that's ln. So negative 3 plus 1 over 2, and 2 plus 3 over 2, which is going to give me negative 2 over 2 and 5 over 2, which is negative 1. And like I said, you can leave it as a fraction 5 halves. So negative 1, 5 halves is about 2 1/2, so it would be right there. And we found all of our midpoints. And like I said, right now we're not going to do anything with this, but later these points become very important for aspects of triangles. We get medians, we get centroids, we get other things that we're going to study later that we'll need to find the midpoint for. So with these, for C, I would do 2 times 6 minus and negative 3. Does anybody want to see the algebra version of it, or just the alternate version? You want to see the algebra too? Okay. I'll do the alternate, and then I'll do the algebra. So I'm going to do 2 times 6 and negative 3 minus 4 and 5. So that's going to give me 12 and negative 6 minus 4 and 5. 12 minus 4 is 8. Oh, I did the wrong thing. Just ignore me. I put the points in the wrong place. Midpoint. 2 times the midpoint. That's the second one. So I get 8 and 10 minus 6 and negative 3. So 8 minus 6 is 2. 10 minus negative 3, that's going to be 10 plus 3. Yeah, M, the midpoint, is what we're multiplying. Algebraically, I would have 4, 5 equals 6 plus x2 and negative 3 plus y2. So that would give me 4 is equal to, or actually I'll write it the other way so it makes a little bit more sense. 6 plus x2 divided by 2 is equal to 4. You're going to need to multiply both sides by 2 to cancel this out. So 6 plus x2 is equal to 8. And then subtract 6 from both sides. so you get 2. And then you'll do the same thing with the y's. I'll have negative 3 plus y2 is equal, divided by 2 is equal to 5. Multiply both sides by 2, and I get negative 3 plus y2 is equal to 10. Add 3 to both sides, and I get y13. And so that would make my missing point to 13.
Can you add because like with the subtraction sign?
Yes. Here?
Yeah.
Yeah, so I want to carry this negative in. So what I'm doing is I'm doing minus 6 minus negative 3. And whenever you have that double negative, it becomes that positive. So for D, and then you do 2 times negative 2, 3, minus 2, 1, which is going to give me negative 4, 6, minus 2, and 1. And since they're both positive, I'm just subtracting. Negative 4 minus 2, so that's 2 negatives. That gives me a negative 6, and then 6 minus 1 is 5. The minusing. If it helps on this, so let's say when I have this, I have negative, and then I have 6 and negative 3. Do this, and then you can rewrite it again, like I did here when I multiplied by 2, or you can do that on the same step. And when you rewrite it, write it as negative 6, positive 3. And then I'll have that 8 and 10 over that, if that would help, because then that'll help you to remember to subtract this and add that.
Yeah.
Does that make sense?